Assalamualaikum and good morning or good afternoon to Madam Rohana. Today, our team gonna do a video presentation about the topic which is technique of differentiation. This is our descriptive title. There are 4 members in our group. Okay, first of all, we're gonna start with introduction. So, what is differentiation? Differentiation is a method used to compute the rate change of a function fx with respect to its input x. This rate of change is known as derivative of f with respect to x. In calculus, there are so many techniques of differentiation, which include the derivative of constant, linear, and power. For the second, derivative of sum and difference. For thirdly, product rule. For derivative of trigonometric, exponential, and logarithm functions. For fifth, chain rule. And lastly, quotient rule. So, to demonstrate the application of technique of differentiation, this video will focus on one of the most vital technique, which is the chain rule. So, we will showcase how the chain rule technique is used to solve the following problem statement.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amin Solehin bin Samsul. So right now I will walk you through on how to solve a derivative of composite function, also known as chain rule question. So for the problem statement, we will take the question from tutorial. So the problem statement asking us to find dy over dx if y equals ln power by 2 x plus e power by 3x. So first, we break the function y equals ln x plus e power by 3x power by 2 into nested variables from the inside out. So let the innermost layer be v, and we will get v equals x plus e power by 3x. And then let the middle layer be u. So u equals ln v, and the original outer functions becomes y equals u power by 2. For the next step, we differentiate each layer independently. So first, the outer layer dy over du equals 2u, and the middle layer du over dv equals 1 over v, and for the last one, dv over dx equals 1 plus 3e power by 3x. Next, we link all the pieces together using the official 3-layer chain rule formula, which is dy over dx equals dy over du set du over dv set dv over dx. And then we substitute our derivative into the formula, and then it becomes dy over dx equals 2u set 1 over v set 1 plus 3e power by 3x. After we substitute our derivative, we will replace the variables u and v with their original expressions to get our final answer. So it will become like this. And then after we done replace the variables, we combine everything into a single neat fractions, and that will be our final answer.
Assalamualaikum and hello. My name is Uwais Karni, and I will begin with presenting example 1. So I have highlighted the keywords here. We have inverted right circular cone describing the shape and the top radius of 4 meters and total height of 12 meters. We know that the fluid is being drained out of the bottom, and that tells us that 2 meter cube per minute should be a negative value in our calculations. So, in the problem section, we are tasked with finding the rate at which the depth of the water is changing. Before we can proceed with any calculations, we know that this is a differentiation question. Thus, we need to have a function beforehand. So where can we get a function? Well, we are told that the question involves the volume of a cone. Thus, we can utilize the formula of volume of cone to get our function. So, as you can see, the volume equals 1 over 2 pi radius squared height. Now, r and h, we only need one of them, preferably h. So what can we do? Well, we know that r is not equal to the big R, which is the full radius, top radius, and h is not equal to the big H, which is the total height. But the ratio of both of these should be the same. Thus, r over h is equal to the total top radius over the total height. And by substituting in the given values of 4 and 12, we can get r equals h over 3. So by substituting that back into our volume formula, we can get the function of v is pi h cubed over 27. Now that we have a function, we can move on to solving the question using chain rule. Given that we were tasked with finding the rate of change of depth, we can conclude that what we are looking for is dh over dt, and based on the chain rule, we can deduce that dh over dt equals dv over dt times dh over dv. And dv over dt is something we already know, as shown in the diagram, which was 2 meter cube per minute, dv, volume, over minute, dt. Now, chain rule can be used in many ways. The earlier formula was just one way, but as you would have noticed, while a part of it was dh over dv, whilst our function was v. So we could also write the chain rule formula as dv over dt equals dh over dt, what we're looking for, times dv over dh, which would be easier to differentiate. Now let's see it in practice. For step 1, we must differentiate our v function, which is simple enough. Just bring 3 forward and deduct cube by 1, and the rest can be done by simple math. Now step 2, we can choose either of the chain rule formulas that we constructed earlier. I'll go with the first one, dh over dt equals dv over dt times dh over dv. Now dh over dv, all we need to do is flip the earlier differentiation result due to it being a fraction. So the question also stated to find the rate the depth decreases where at the instant the water depth is 6. So by letting depth h be 6, we can get the final answer of negative 1 per 2 pi. And remember, we need to keep the negative because the water is exiting the container.
Hello, my name is Mama Zulfihan Ibn Mama Hilmi. So right now I will present conclusion for this boss problem. In conclusion, boss problem show how important the chain rule is for connecting different changing measurements. This example proves that the chain rule is useful for solving real-life situations involving changing measurement.
So this is our reference for our video. So that's all from us. Thank you and good night.